Hello, welcome to the next video in a playlist that I'm calling Complex Variables, where we're going to create a playlist on complex analyses, and we're providing background material first, and we're in the trigonometric portion of our background material before we jump into complex analysis. And today's topic is the sine and cosine of the inverse tangent function. So the formulas that we want to drive, so this is our goal is to drive these two formulas. The sine of the arctangent of x is equal to x over the square root of 1 plus x squared. And the cosine of arctangent of x is equal to 1 divided by 1 plus x squared. Square root of that. Okay, so let's start the derivations, but first briefly talk about nomenclature. First, note that the inverse tangent is the same as the arctangent. Okay, so these two notations are the same. So if we take the inverse tangent of theta, that's 100% equivalent to the arctangent of theta. Okay. Now the inverse tangent can be mistaken for the reciprocal, and that's why I prefer using arctangent. Then there's no doubt. So the tangent, the inverse tangent of theta is not equal to 1 over the tangent of theta. This exponent's not really an exponent when it's -1. It means inverse tangent. But if it's a positive number, say 2, then it is an exponent. Tangent of x squared is equal to tangent of theta times tangent of theta. Okay, so we're going to use arctangent instead of this notation. So next, let's examine this right triangle. So it's a right triangle, side lengths 1, x, and the square root of 1 plus x squared. Angle theta. Now we're going to do three operations, three simple operations, and I think you'll be able to remember these because as I scroll, the triangle is going to go away. If we take the tangent of theta, that is x divided by 1, or just x. If we take the sine of theta, that's x over the hypotenuse, the square root of 1 plus x squared. If we take the cosine of theta, that's 1 divided by square root of 1 plus x squared. And those are the three operations you're going to have to remember. Or if you write this down, you can follow along. So note the tangent of theta. The tangent of theta is x over 1, like we said, which is just x. Now let's take the arctangent of both sides of this equation. So if we take the inverse tangent of theta, or the arctangent of theta, we get theta, right? So the arctangent of theta is just theta. And then the arctangent of x. Okay? So far, so good. Now let's note the sine of theta, right? So the sine of theta, if we were to just look at the triangle, we'd say, oh, that was opposite x over the hypotenuse, square root of 1 plus x squared. But if we plug in what theta is, the arctangent of x, we can put that there. That's the sine of the arctangent of x is equal to this. And that was actually one of the formulas we wanted to derive. Next, let's look at the cosine of theta. Now the cosine of theta, if we just use that triangle, then we would say it's 1, the adjacent, divided by the hypotenuse, square root of 1 plus x squared. And that's it. But since theta is the arctangent of x, we can put it in there. So the cosine of the arctangent of x is equal to this fraction. And that's one of the formulas we wanted to prove. And so these are the two formulas that we just illustrated and how they're derived. Now there's one little caveat, and that to be technically correct, we should say plus minus in front of that x and a plus minus in front of that y, since both of these could be positive or negative. But okay, well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.